Greetings, this is Phi. I was hoping to create a quick video today to begin to create some orientation around the polynumbers project. So hopefully what you're seeing on the screen right now is the GitHub page under my Geometor organization for the polynumbers project. And I'm beginning to assemble some of the code that I had. Some of it's based on things that Federico has created. And I know that we need to begin a dialogue somewhere and wanted to create a quick introduction into this. But as a part of my work today, I've been trying to figure out if I could begin to plot some of these curves with the same tools that I've created for the Geometor project for doing Euclidean geometry. And the answer is yes. And this is one of the results. So this is the first 20 curves for the spread polynomials. And it's really showing up very nicely here. You can see these wonderful ghost curves that are showing up and ghost lines. There's some really interesting radial pattern that's happening here on the left-hand side. And when I saw this for the first time from Dr. Wildberger's lectures, I was really enthralled with it, and I felt like this was a lot of the same thing that I've seen in musical harmonic analysis and also in my golden ratio work. And and it took today just finally looking at this to recognize that the golden ratio is all over this diagram, particularly the diagonal line that is running across the figure. And it just took me taking my golden calipers and holding them up to the screen and recognizing that many of these points here are creating a golden section harmonic. So my next question was, well, how to prove that? How to actually do that algebraically? And so a part of my exercise today was to do that. And what I found was that at the fourth degree, at the fourth degree, there are 7 golden sections across the line. And I'll demonstrate that here in a moment. But let's just, take a step back from this and go right to the beginning. And you can see as we're building up each of the levels of curves. And when we get to the 4th level, we have a series of intersection points here. And that's what I was kind of seeking to do. If we go to higher degrees, SymPy is having a bit of a problem with that. I think there are some workarounds with it. It's quite complicated, and and probably is going to require some expertise in order to figure that out. But you may be able to see the golden ratio harmonics that are running across that line right here. And if I jump to the end of this, excuse me. You'll see that I'm actually plotting points here, and that's from my Geometor Explorer, capabilities. So I'm actually doing the work algebraically of solving for the intersections, and I can do that up to the 4th degree right now. One of the things I didn't expect to find the golden ratio, what I was originally quite curious about was finding points along this ghost curve. And if we could identify 5 of them algebraically, we would be able to actually define the equation for that ghost curve, wouldn't we? So I think I'm very close to that, actually. And I believe that, at that 4th degree level, we would have enough points to do it. So I was really kind of rushing to get a video out. I wanted to do this before the weekend because I've got some plans and I'm going to be away. But I wanted to share some of this, and I hope that it kind of inspires people's thinking, and we can start to think about how we might work on this together. Just to show you a bit of the code here, let's exit out of this. Here on the left side of the screen is the spreads script, and basically we establish a count for the number of iterations that we want to go through, and then there's some work around setting the folder where we're going to save our images. And and then we we just go through a for loop and create the number of spread polynomials for each of the counts. And then we do some setup for the plotting that we're going to do. And then a little bit of analysis. And so if the index of the polynomial is greater than 0 and less than 5, then we seek to find the roots of the intersection of the first line, which is the first curve in the series, and the current line, and then from there establish sim-pi geometric points, and then we can plot those points. And as I'm building up this routine, I'm taking a snapshot at each level, and those are getting saved to a folder in my sessions folder, and that's what we're looking at over here on the right hand side. So that's the summary screen, and we can go backward and look at each of them. So lots of opportunities for analyzing, animating, looking at various properties across this. You may have noticed in the code I'm extracting the coefficients and those kinds of things. We'll be able to look at patterns within the matrices that we'll develop and stuff. But I thought this was a good start, and I wanted to just get something recorded so that we can start a dialogue here. You're going to see a lot of functions that you're not going to recognize. Some of them are based in the Geometor Explorer library. You can also find that. Let's scroll down here. If you go to Geometor, Geometor Explorer is here, and again, this is barely documented. Most of the stuff I've just been pulling together in the last few months. But, I think I've got a good foundation here for beginning to explore some things. So let's just run that script. I want to show it running. So this is the spreads polynomial script. And so I'll just hit F5 here in my editor, and I'm just going to give it another folder to put those images in. And it runs through, does all the calculations, and we just ran up to 5 here. And now we're in an interactive display, and I've got a few things, so I can actually click on these points, and you can see that this one is at 3/4 by 3/4. This one is 1/2, 1/2. But then we have a few interesting ones that have the square root of 5 involved in them, and these are the ones that are contributing to our golden ratio harmonic, and it's kind of running in both directions here. I haven't had a chance to actually plot the golden sections. That will come in a bit, but here in the code you can see that we provided 7 points to my golden section finder, you might call it, and out of those 7 points it identified 35 combinations of those points that could be used, of combinations of 3 points out of the 7 that could be used as to identify golden section. And out of those 35, it found 7 golden sections right here. And then this is a listing in kind of sim-pi technology of each of the segments and the points that define them. And so you see these square root of 5 figures that are really what are contributing to the golden section. So there'll be more analysis that will come out of this in the future. I'm looking forward to introducing the tools that I've been building with Geometor Explorer as well. There's a lot that's coming, and I hope you find this interesting. It seems like an interesting opportunity for uncovering some really cool things. So thank you for your time.